Let me ask you something that nobody in the car industry wants you to think about. What if everything you believed about how a car should be built was completely wrong? What if 100 years of engineering tradition was actually holding us back from something far better? Because right now, in 2026, a company that used to make your phone is making the entire automotive world look slow, outdated, and frankly a little embarrassed. And by the time this video ends, you will not look at any car the same way ever again. Before we go any further, if you are the kind of person who wants to know what is actually happening in the world of technology before everyone else finds out, hit subscribe right now and join the Beyond Human family. This is exactly the kind of story we live for. Now buckle up, because this one is going to hit different. Cast your mind back to 2021. Xiaomi, a brand most people knew for selling affordable smartphones and rice cookers, stood up in a boardroom and made an announcement that genuinely shocked the automotive world. They said they were going to build an electric car. Not just any car. A car that would beat the best that Europe and America had ever produced. And the reaction from the experts in Detroit and Stuttgart was immediate and unanimous. They laughed. Veteran engineers with decades of experience looked at this consumer electronics company and said, "You have absolutely no idea what you are getting into." The complexity of building a real automobile, the safety certifications, the supply chains, the precision manufacturing, all of it would crush a tech company that had never built anything with 4 wheels before. That was their prediction. Fast forward to today, and those same experts are not laughing anymore. They are scrambling. Because what Xiaomi has just done to the science of building cars has not just beaten the traditional players at their own game. It has changed the game itself so completely that the old rulebook is now completely useless. But to really understand how this happened, you have to understand the man who drove it forward in the most literal sense possible. Lei Jun, the founder and CEO of Xiaomi, recently did something that no executive at Ford, Mercedes, or Toyota would ever dream of doing. During the launch period of his new electric vehicle, he personally climbed into the car and drove it from Beijing to Shanghai. That is 816 miles. That is 1,313 kilometers. And he did it on a single battery charge. On a live stream. For over 15 continuous hours. When people watching online begged him to stop and sleep, his answer was brutally honest and completely unforgettable. He said he could not sleep because if he closed his eyes for even a moment, someone would accuse him of faking it. He needed the world to watch every single kilometer in real time with no cuts, no edits, and no possibility of doubt. Think about what that says about this man and this company. He is not hiding behind press releases and carefully managed media events. He is personally, physically, publicly staking his reputation on the performance of what his engineers built. He once said that a person who is truly successful wakes up every morning for only 2 reasons. 1. Because they genuinely love what they do. 2. Because they feel a deep and real responsibility to the people who trust them. That combination of passion and accountability is what drives everything Xiaomi has built. And it starts with a discovery that is going to completely change how the world thinks about metal. Here is the problem that has quietly haunted car manufacturers for 100 years, and that almost nobody outside the industry ever talks about. When you build a large metal component for a car using traditional methods, you eventually have to bake it. You take your cast aluminum part, you put it into an enormous industrial oven, and you heat it for hours until the molecular structure inside the metal rearranges itself into the right alignment. This process is called heat treatment, and it has been the standard approach since the very beginning of the automobile. But it has one fatal flaw that nobody has ever been able to engineer their way around. Heat causes the metal to warp, not dramatically, not visibly, but in tiny microscopic fractions of an inch that ripple through the part unpredictably as it cools. And in modern precision manufacturing, Those invisible fractions of an inch are the difference between a car that feels solid and expensive and one that develops rattles and wind noise and misaligned panels after a few years on the road. Every manufacturer knows about this problem. And for 100 years, every manufacturer has been managing it rather than solving it. Xiaomi decided they were done managing it. They were going to eliminate it completely. So they built something extraordinary. They created a deep learning artificial intelligence system, and they called it the material genome. And they gave it one mission. Do not find a better way to deal with warping. Find a completely new metal that cannot warp at all, because it does not need heat treatment in the first place. What followed was one of the most remarkable feats of computational science ever applied to industrial manufacturing. The material genome ran simulations on more than 10,160,000 different possible alloy combinations, testing how aluminum mixed with silicon, magnesium, and rare earth elements would behave at the molecular level under every conceivable condition. Now pause and think about what that number actually means. If a human scientist tested one alloy formula per day, every single day, without ever taking a weekend or a holiday, completing that same task would take over 27,000 years. The AI did it in a fraction of the time. And what it found at the end of that search was something genuinely new to materials science, something that had never existed before. They called it Titan's metal. Titan's metal is a patented alloy that comes out of the casting mold already perfect. The moment it cools, its molecular structure is naturally and completely aligned without any oven, without any heat treatment, without any of the warping that has plagued traditional manufacturing for a century. It is strong where it needs to be strong. It is flexible where flexibility is needed. And it is dimensionally stable from the instant it solidifies. This is not an incremental improvement on existing aluminum alloys. This is a completely different way of thinking about what metal can be when you stop accepting the limitations you inherited and start using computing power to design entirely new materials from scratch. The West has traditionally approached this problem by perfecting the process. Better ovens, more precise cooling, tighter tolerances in the machining that corrects the warping after it happens. Xiaomi looked at that approach and asked a different question entirely. What if we just invented a metal that makes the oven completely unnecessary? That single question, and the AI system built to answer it, is what we mean when we talk about software-defined metal. We are no longer in the era where the best engineers win by mastering the processes we already have. We are in the era where the best algorithms win by creating materials that never existed before. Now you have a revolutionary metal. But you still need a machine powerful enough to do something useful with it. And this is where things get almost unbelievably impressive. While the automotive world has been amazed by Tesla's 9,000-ton gigapress machines, which themselves represented a massive leap beyond anything traditional manufacturers were doing, Xiaomi looked at that benchmark and decided it was not enough. So they built something bigger. Their hypercasting machine operates at 9,100 tons of clamping force. It covers the floor space of 2 full professional basketball courts placed side by side. The machine itself weighs over 1,000 tons. And it operates with a surgical precision that feels almost impossible given its size. It takes liquid Titan's metal heated to nearly 1,300 degrees Fahrenheit and injects it into a precision mold at such extreme speed and pressure that air bubbles physically cannot form anywhere in the part. This matters more than it might sound. In high-performance engineering, microscopic air pockets trapped inside a metal component are invisible ticking time bombs. You cannot see them from the outside. The part looks completely solid. But under stress, those hidden voids become the points where cracks start and failures begin. By eliminating them entirely through sheer injection speed, the finished parts come out with an internal density and structural integrity that was previously only achievable in aerospace manufacturing for jet engine components. Here is where this technology becomes directly and personally relevant to you as someone who owns or plans to own a car. A conventional vehicle's rear structural section is built from approximately 72 separate stamped steel pieces held together by around 840 individual weld points. Every single one of those welds is a potential failure point. It does not matter how good the welding robots are or how rigorous the quality control process is. Over 10 or 15 or 20 years of road vibration, cornering stress, thermal expansion, and weather exposure, those welds begin to fatigue. That is where the rattles come from in older cars. That is where the squeaks come from. That is where hidden rust starts. That is why a car that felt tight and solid on day one gradually feels looser and noisier and older as the years pass. The hypercasting machine replaces all 72 parts and all 840 weld points with a single continuous seamless piece of solid tightened metal. There are no joints to rub together. There are no welds to crack. There are no seams for water to enter. The car does not age the same way a traditionally built car ages, because the fundamental source of that aging has been completely removed from its structure. And this single casting is 17% lighter than the steel assembly it replaces, while simultaneously reducing the road noise that reaches the cabin by 2 decibels. In automotive engineering, 2 decibels is a very significant and clearly perceptible improvement in refinement and quietness. And the production time for this entire rear floor structure, all 72 parts replaced by one, is exactly 100 seconds. Not hours. Not minutes. 100 seconds, and then immediately scanned by industrial X-ray and laser measurement systems to verify absolute perfection before it moves forward in the assembly process. If you are watching this and thinking that this is the kind of content you want more of, this is your moment to subscribe to Beyond Human and turn on notifications. We find the stories that are actually reshaping the world, and we break them down so they make real sense. Do not miss what is coming next, because the battery section of this story might be the most mind-bending part of all. Now we need to talk about the battery, because Xiaomi did something here that required the entire engineering team to throw out every assumption they had inherited from previous electric vehicle designs. In virtually every electric car on the road today in America, the battery pack is treated as a separate module. It is a large heavy box engineered independently of the car structure, then bolted to the underside of the floor. It stores energy and delivers it to the motors, but it contributes nothing structural to the vehicle. It is pure weight being carried around. The Xiaomi engineers looked at this arrangement and asked a question that seems almost obvious in retrospect, but that nobody had fully committed to before. What if the battery stopped being a passenger and became the backbone of the car itself? The answer to that question became their cell-to-body technology, CTB. In this system, the battery cells are integrated directly into the vehicle's load-bearing structure. The top face of the battery pack literally becomes the cabin floor. The structure that holds your feet is the same structure that contains the energy cells. They are one unified system, not two separate things bolted together. This integration creates a level of structural rigidity that is almost incomprehensible for a production sedan. To pull this off, the team made one brilliantly counterintuitive decision. They flipped every battery cell upside down. This sounds simple, but the implications are enormous. Every lithium battery cell has a pressure relief valve built into it. This valve is a safety feature that vents hot gases if a cell ever overheats dangerously. In a conventional battery pack, these valves face upward toward the cabin and the passengers. This forces engineers to install thick, heavy layers of protective shielding between the battery and the floor to protect the people inside. Those layers add height and weight that the car has to carry everywhere it goes. By flipping the cells so the relief valves face downward toward the road, Any potential venting event directs pressure and gases away from the passengers and into the structural floor beneath the car instead of toward the people above. This allowed the engineers to remove those bulky protective layers entirely. The result is a combined battery and floor system with a total thickness of just 4.7 inches, the thickness of a hardcover book. Because the battery sits so low and so flat, the entire car sits closer to the ground than would otherwise be physically possible. The center of gravity drops dramatically. The handling becomes extraordinarily stable at high speed because physics dictates that a lower center of gravity means far less tendency to roll or become unsettled in a corner. And then there is the stiffness number that makes every automotive engineer stop and read it twice. Torsional stiffness is the measurement of how much a vehicle's body resists twisting under load. The Ford F-150 Raptor, one of the most capable and rigidly built performance trucks in America, registers approximately 18,440 foot-pounds per degree of torsional stiffness. That is an impressive number by any conventional measure. The Xiaomi sedan measures over 37,600 foot-pounds per degree. It is more than twice as stiff as the Raptor. And then consider this. It is stiffer than a Bugatti Chiron, a car that costs several $1,000,000 and represents the absolute maximum of what decades of European hypercar engineering can achieve. A $35,000 electric sedan from a company that used to make smartphones is structurally more rigid than one of the most exclusive automobiles on Earth. When a chassis has this level of stiffness, the suspension works exactly as it was designed to work on every single corner of every single road, because the structure never flexes to disturb its geometry. The tires stay in perfect contact with the pavement. The car goes precisely where you point it. The safety systems have accurate data to work with because nothing in the structure is moving when it should not be moving, and the market has responded to all of this in a way that nobody, not even the most optimistic Xiaomi analyst, predicted. When the YU7, their new 5-seat electric crossover, opened for pre-orders, 289,000 people reserved one in the first 60 minutes. Not the first day. Not the first morning. The first hour. For context, that is the kind of demand number that major technology companies celebrate when it happens over the course of a full product launch week. Xiaomi hit it before most people had finished their breakfast on pre-order day. Industry analysts are positioning the YU7 directly against the Tesla Model Y, which has been the world's best-selling electric vehicle and the undisputed benchmark for electric crossovers for years. The comparison is aggressive and intentional. The YU7 starts at 253,500 yuan in China, which is approximately $35,000. That price puts it below the equivalent Model Y configuration, yet it comes with hypercasting technology, Titan's metal, cell-to-body integration, a torsional stiffness figure that beats Bugatti, and a 1,548 horsepower drivetrain in top specification. This is not just a competitive product. This is a direct and confident statement that the era of paying a premium simply for a brand name is ending fast. What we are watching in real time in 2026 is something that the automotive industry has not experienced since Henry Ford introduced the moving assembly line over 100 years ago. The rules of the entire game are being rewritten by someone who was not supposed to be playing it. Xiaomi started with no legacy infrastructure to protect, no established manufacturing processes to preserve, no century of institutional habits to overcome. They started with a blank canvas and the most powerful computational tools in human history, guided by a leader who was personally willing to drive 800 miles through the night to prove that what his team built was real. Every major automaker on Earth is watching what is happening right now, and they are asking themselves the same urgent and uncomfortable question. How do we respond to something that changed so many fundamental assumptions simultaneously? Because it is not enough anymore to build a better version of what you have always built. The customers can now see what is possible when someone starts from scratch with AI-designed materials, AI-optimized structures, and a manufacturing process that replaces hundreds of individual parts with single perfect castings made in 100 seconds. The era of the software-defined car is already here. But Xiaomi has taken it one step further into territory that nobody else has reached yet. They have delivered the era of the software-defined metal, the era of the AI-designed structure, the era of the battery that is not a passenger but a backbone, and the era of a company culture where the CEO will go without sleep for 15 hours because he owes it to his customers to show them the truth in real time with nothing hidden. This is what disruption actually looks like when it arrives in full force. Not a press release. Not a concept car behind velvet ropes at a motor show. 250,000 pre-orders in 60 minutes and a lap time faster than a Porsche. So here is the question we genuinely want you to think about and answer honestly in the comments below. If you walked into a showroom tomorrow and the Xiaomi YU7 was sitting next to the Tesla Model Y, knowing everything you now know about how these two cars are built, knowing about Titan's metal and hypercasting and cell-to-body technology, and that stiffness number that beats Bugatti, and knowing that the Xiaomi is priced lower, what would you do? Would you go with the established name and the familiar ecosystem? Or would you follow the engineering and the data wherever they lead you, even if that destination is a brand you never expected to trust with your family? And what do you think American manufacturers need to do right now to stay relevant in a world where the rules just change this dramatically this fast? Drop your honest thoughts below. The conversation in the comments is going to be worth reading. Like this video if it gave you something real to think about, and subscribe to Beyond Human because we are just getting started. See you in the next one.